Hello, I'm going to tell you a little bit about the difference between full scale, large scale, and small scale. So in mechanical drawing, mechanical drafting, you would have an object usually. It's usually a small object, it's some part, and you want to draw it so that then someone can go manufacture it. So if you're going to draw it actual size, or actual scale, here I'm just taking an incremented straight edge, and it is 40 increments across, okay? And so I will measure that with my stay over there. So I will measure that with my compass. Silky, stay over there. Measure that with my compass. Okay, that's the diameter. I need the radius. Okay, so it was a full scale diameter of 40, and so a radius equals 20. Now, this is a cheap compass, so it's going to turn out crappy, but it'll give you, move cat, move, move. It'll give you the general idea. Okay, so this is full size, it's actual size, so it is full scale. So then for this, here, to figure the diameter, see it's off a little bit. I blame my junky equipment. So this would be 1:1 for the RF, and for ER, it would be 1 inch equals 1 inch. Okay, full scale, 1:1. Well, now let's say we wanted to blow this up. So we wanted to make it large scale because the object is larger. Now we have to say, okay, the diameter is no longer going to be 40 of those increments. Let's say we want to explode it by 2, then the diameter is going to be 80 and the radius is going to be 40. So now half of something on here is going to equal 1 in real life. So let's see. So now we want 40. It becomes the radius. I need a little more room. Wishing I'd done this on white paper. All I had was blue. Okay. Again, got this at Food Lion, like I ever use a compass in real life. There we go, that's pretty good. Okay, so now for the equivalence relation, 1 inch equals, see in this instance, here's 1 inch, goes a little bit past there. Now it takes 2 inches to get to that same place. So 1 inch here, oops, sorry, equals ½ an inch in real life. Remember, it's always paper to life. And the same thing here. Paper dimension equals, yes, you're cute. Come on. I know. You always want to be a part of videos. Equals life, whatever the unit is. So that's large scale. Now this is for mechanical applications. But what if we want to draw it small scale? So it appears smaller than real life. Well, let's go divided by 2, make it easy on ourselves. So the diameter is going to be 40 divided by 2, and the radius is going to be 20 divided by 2. Again, it's the same object. We're just drawing it at different scales. Okay, so then our diameter is going to be 20, our radius is going to be 10. So here, there's that. There we go. Little tiny half-size bottle cap. Oop. Ta-da! Okay, so now the representative fraction here is going to be that one of these is actually equal to 2 of these. And then for the equivalent relation, it's going to be 1 inch equals 2 inches. Now you may be saying to yourself, these numbers are the same. But that's because the units are the same. I could have said 1 inch equals 1/6 foot. Then the numbers wouldn't be different. You know, 1 inch equals 1/12 foot. 1 inch equals 1/24 of a foot, or whatever their decimal equivalents are. And then they wouldn't be the same. The only reason that these numbers seem the same, I'm not trying to confuse you, is because I'm using the same units here. If I was using different units, then I would have to convert. Okay, this is mechanical. Small scale things appear smaller on the page, large scale things appear larger on the page. Now let's talk about civil, GIS, and architectural applications. So instead of drawing a little thingy, I am going to draw a little fake house, an elevation. And in this application, full scale, small scale, and large scale mean different things. In these applications, it's not the size of the object that tells whether it's small or large scale. It's how much area you can see. So this is all about area. So if here's our house, our low elevation, this is how I drew my houses when I was little. Don't know why. Okay, so let's just say, all right, so this is, we'll call it 35. So the length equals 35. So if I'm going to show more of this landscape, then this actually has to get smaller because it's the same size paper. So here, the length is going to be 17.5. Remember, it doesn't matter if you know what a scale is, it doesn't matter. And I'm just freehanding it because it doesn't matter. Just want you to get the idea. Okay, so that's large scale because now I can, show the tree and that there's a row of bushes there, okay? But if I want to zoom in on something, then it's going to be, the length is going to, of this line is going to be bigger because I'm going to focus in on something. So now the length equals 70. Remember, I've got the same sheet of paper though. So maybe I'm just focusing in on the front door or something. Okay, so I don't have room for everything that I did in the large scale because this is showing a large area. This is showing actual size, pretend, and then this is small scale, zoomed in on something small. It's showing a small area. But the RF and the EF would be still using the same, RF and ER would be using the same math, okay? So here, it's still 1-to-1 and 1 foot, 1 inch equals 1/12 of a foot. And then here, 1 inch equals 2 inches. 1 inch equals 1/6 of a foot. Okay, because I multiplied everything. So it'd be 2/12, which is 1/6. Okay, so then here, we are dividing by 2, so we made this side bigger. Here we're going to say 1 unit on the paper is actually half a unit in real life. So you do the opposite of that. And the equivalence relation is going to be 1 inch equals 1/24th of a foot. Notice 12 times 2, 12 divided by 2. That is just to show what it is on paper first, and then either some sort of colon or paper 1 inch equals life, whatever units life is. So I hope this was clearer than mud, and if you have any questions, send me a message. Thanks.